Hi, good afternoon, everyone. My name is AfOLABI. I'm the YAM data manager and the ontology curator. I will be giving an update on database storage of YAM laboratory quality data, progress, and next step. Breedbase is an open source, web-based software available to help plant breeders. It includes phenotypic, genotypic, and environmental dataset. It has analysis support for single and multi-location trial. It also includes support for PhenoApp, which are a suite of data collection application running on mobile. It also includes support for BRAPI, which is a breeding API that allows integration of tools across databases. So think about having a tool hosted in another database. You could invoke a function to call the tool and make use of it within your own database. Yambase is an instance of Breedbase, and these are other sister databases used within the root, tuber, and banana community. The status of the database, there are currently 224 users, 8 breeding programs, and we have 69,000 accessions coming from 593 phenotyping trials. There are 214 trait tabs described, and there are 93,000 phenotypes, which is the total trait measured. And there is 67,000 plot, and there are 37 locations. These are the different trial types we have in database, and the stock types, and the breeding programs which are managing their trials within the database. Yambase improvement, we have improvised number of tools within Yambase. The label designers will allow easy plot labeling in the field based on the design that we have. There's a trial comparison and graphical filtering tools. This tool become more important, most especially for the product profile tool that has been implemented. The tools allow the user to search for a session based on set threshold by trait. You could combine multiple traits and say, okay, database, can you please look for a session that meet the certain criteria? Uh, we have we have tools that can allow you incorporate treatment and multi-factor level within your design. So if you have trial that has factorial arrangement, you could easily incorporate that into the existing design that we used to have. Crossing tool, there is a new crossing application called Intercross, and the crossing tool within database as an improvise to receive data from the Intercross application. NIRS, the NIRS tool within the database has evolved, so it has gone beyond just uploading. In the past, we had challenges on how to upload the NIRS data, but now it's more than just uploading data. We could do some analysis with the NIRS data. Um, Analysis in terms of single location trials, we have the mixed model for single trial analysis, and we have stability analysis for multi-environment trials, site regression, heavy analysis, and NIRS, I think I mentioned that. The YAM trait ontology, uh, currently we have 6 trait classes described in the ontology, and these are the agronomic traits, the biotic traits, the morphological, phenological, physiological trait, and quality trait. Uh, the ontology is a component of the database, and out of from these six trait classes, we have 214 trait terms described. Out of these, there are 39 traits that are associated with quality. We have the Excel-based template, which is a trait dictionary, which is used for creating the YAM trait. However, the YAM base make use of the Hopo format, which is what the uploader use within in the database background. However, we keep both in sync, the Hopo and the trait dictionary. Um, and this is the link to the ontology on the crop ontology website. The current status, at the moment, we have all trait terms all described within the quality parent class. As such, we are thinking of a way to disaggregate the trait terms rather than having them all lumped within the quality class. We want to disaggregate by the attribute. So some of the attributes identified at the moment is appearance, odor, taste, texture. And so in the way we want to use this to reorganize the ontology. This has been done for the Excel-based template with the trait dictionary, and we are working out how to get this done within the Hubble file. As such, how it implemented on the Yambase. Currently, we have 156 trials that are associated with quality trait terms. 156 is not it's a fair number, I must say. We have 593 trials, so 156 trials is a fair number, so to say. But however, I think we might need to do more because we haven't captured so much of the different quality trait that I think we should have. Expected data set. We are looking at two kinds of data set, the unstructured and the structured data set. The unstructured will come from the NIRS, and the reason why I call this unstructured is because the different columns in the NIRS data cannot be ontology annotated. So we have to store each row of the NIRS data and each get mapped to the plot and the assertion. So we will be expecting data set from the benchtop NIRS. I wouldn't know if there will be data set coming from the portable and the handheld NIRS. For the structured data, we'll be expecting data from the wet chemistry lab analysis. Um, these this will be easier to do because once we get the data, we extract the trait, we get description for the trait, the method being used, the unit, and we define this in the ontology. Once we have them defined in ontology and an assigned ontology ID, we can upload the data. So the process for this is more of, have it ontologized, and we have the data upload in database. The moment we don't have any data set associated with the physical, chemical, or the biochemical trait, but we have some data set from the functional properties, which are terms like swelling power, peak time, pasting temperature. But these are small number of trial. I think we can do more than this. But it all boils down to we need data set. So progress with NIRS data upload. The NIRS section within the database is divided to five menus. So we can upload your train model, you can predict phenotype, you can plot, then you can download your NIRS data. So with the upload, after uploading, the database does is to use the NIRS data you have uploaded as a validation set, and it use that to retrain the model, and it predict a phenotype. Currently, the trait being trained within database is dry matter, and the user can have access to the spectral relationship matrix. This uses the similar concept of genomics, and this approach is simply a phenomics approach. And this is simplified within the database. We'll get to the slide that show how you can understand how this work. So at the moment, the database is structured for the NACE pipeline based on the protocol. So each device you use will have a defined protocol. So if you have four kind of device, if you have four kind of devices, you could describe four different protocols, and the pipeline is separated for these devices. So at the moment, the default protocol is the SIO, which is a handheld, but we could define protocol for any device, like the benchtop. We can have that described as well. The schema of the spectral analysis tool. This is the whole schema of the spectral tool in the database. It's all embedded on R. There is a R package called Waves, and that's the library running at the background doing most of the analysis. And this is the schema. It filters after loading your raw spectral data. It filters the data based on a known algorithm like the Savinsky-Golay and some of the popular algorithm within the NIRS framework. And these are the functions that does cross validation and have your model safe. And at the end of it, you have your predicted phenotype. So training manual. So using the NIRS is easy. Just navigate to the About tab in the database. Go to the manual, then you can find manage spectral data. You see all the steps on how to manage spectral data. Our next step, we want to create subclass in the parent quality term rather than lumping them. Like I said, we want to kind of reorganize by attribute, and we need to add new terms. We need to describe. So, and this is still hinge on having data sets. Once we have the terms, we describe the method, the trait definition, the skills, and it's all about getting the data. We need the data. Um, then I must say for most of the lab data we need, it's good to have the protocol, and this protocol can have the protocol on Yambase, just like we've done for some trait in database. More like an SOP, more like an SOP. So I must emphasize on the term request form. The term request form is used in making requests for trait, and the good side of this is on the part of the user can define the trait, define the measurement explicitly, and on the part of the curator, it allows us track the genesis of the trait, what validation uh, procedure was embarked upon when the trait was requested, so we could track back as many years as possible. So any new trait that is coming has to pass through the trait request form, has to be requested using the request form. I mean. Thank you for listening. This I would like to acknowledge the Boy Something Institute folks, Nama Mendes, Lucas Mola, Chris, Nick, Alex, the crop ontology team, Marie Angelique Laporte, Elizabeth Arnold, African Yam folks, Hi T, RTB Food. Thank you for listening once again.